Hello guys, you are welcome to this lecture. In this lecture, we are going to look at some physical chemistry questions and their answers, and also go in detail to talk about the calculation questions in pharmaceutical chemistry, not physical. Now, but before we continue, please make sure that you subscribe to the channel, turn on the notification button so that you'll be notified whenever we post a new video. Also, make sure that if you have any complaints on any understanding, please you can reach us via our social media handle that is there. We have the YouTube channel, of course, which is this channel. You can comment on the and also you can send us a message via our WhatsApp group, which is also listed here. Now, the first question here says, which of the following is the odd term in this group? Now, before you be able to provide solution to this question, you must have an idea of what the periodic table looks like. Okay, you must have an idea of what the periodic table looks like. Now let's go to the periodic table and see how it looks. Now we have the group 1 element. In the group 1 element, you have you have hydrogen, then this is lithium, this sodium, this potassium, this rubidium, this cation, and this is what? Francium. Are we getting it now? If we come back here, you discover something. The question that was given to us, you have lithium, you have cation, we have rubidium, we have rhodium. Now, if you take a look at all the elements, you agree with me that they are all present in group 1. This is lithium, this rubidium, this cation. But if you look at them, you now see rhodium in group 2. It means that rhodium is the odd one there because it's a group 2 element and not a group 1 element. Hence, this one is the odd one. And we are looking for the odd one, so the odd one becomes the right answer. All these three, they are what? Group 1 elements. Is that okay? All these are group 1 elements. So this is basically how to solve a question like this. Which of the following is the odd term in this group? You look at them, the ones that are in the same group, you classify them. Now, this classification of this element may be based on different criteria. It must not be limited to the group alone. It may also be limited to the kind of color they exhibit, their chemical properties, etc. Of course, we know that every element in the same group have the same chemical properties. Are we getting it now? But the criteria for actually choosing which is odd and which is not odd is not based on only the group number. It may be based on other criteria. Are we getting it now? So please, you should take note of it when you are giving question. But this one, we can easily see that the first 3 elements are in group 1 and the last one is in group 2. Hence, since the 3 are in group 1, you agree with me that they have similar properties, while the one that is in group 2 is different from them because it has different property. Hence, D is the correct answer. Now let's look at number 2 question. There is a diagonal relationship between, now the diagonal relationship is between elements in the periodic table that are adjacent to each other. Elements in the periodic table that are adjacent to each other in such a way that one is a group higher and also a period higher. So if we look at the periodic table, you agree with me that lithium is a group higher while magnesium is a period higher, because lithium is in group Group 1. Lithium is in group 1 rather, and also in period 1. While magnesium is in group 2 and also in period 2. So this kind of relationship between atoms in such a way that the 2 atoms are just adjacent to each other, that one is one period and one group higher, you call that kind of relationship diagonal relationship. What do you call it? Diagonal relationship. Is that okay? So if we look at this critically, you agree with me that lithium and magnesium, lithium is one group lower than magnesium and also one period lower than magnesium. So you agree with me that these two will have a diagonal relationship. So we can say that there's a diagonal relationship between these 2 elements, lithium and magnesium. Now, sodium and calcium, they can be a diagonal relationship. Potassium and strontium, they can be a diagonal relationship. Now, in the same way, if you look at beryllium and aluminium, beryllium is in Group 2, period 2. Aluminium is in Is in group 3, period 3. Hence, there can be a diagonal relationship between beryllium and aluminium. Reason being that they are one group and one period what higher than the other. Now you agree with me that boron and silicon can have a diagonal relationship too. Why? Boron is in group 3, period 2, group 3, period 2. Why this one is in what? In group 3, period 3. So there can be a diagonal relationship between this. Now also look at aluminium. You discover something. Aluminium is in what group? Group 3, period 3. Group 3, period 3. Why this is in group 4, period 4. Group 4, period 4. Sorry about this boron and silicon, but there can be a diagonal relationship, but let's not. They are adjacent to each other. You see the diagonal relationship. When you say diagonal, it's something like this, okay? Now, but that of aluminium is in group 3, period 3. Germanium is in group 4, period 4. So there can be a diagonal relationship, okay? So when you have this kind of relationship, like gallium and tin, there can be a diagonal relationship. Carbon and phosphorus, there can be a diagonal relationship. So when one is one group higher and one period higher, you call it what? Diagonal relationship. So let's go back to our values given here, or the questions given. You have, there can be a diagonal relationship between sodium and magnesium. Now sodium is in what group? Group 1. Magnesium is in what group? Group 2. Sodium is in what period? Period 2. Magnesium is in what period? Period 2. So this, they can't be a diagonal relationship. Let's look at aluminium and germanium. Aluminium is in what group? Group 3, period 3. So we have group 3 for aluminium, period what? 3. Germanium is in what group? Look at germanium in the periodic table. Germanium is in group 4, period 4. So we have it group 4, period 4. So you see that this one is one group and one period what? Higher than it. And if you look at them very well in the periodic table, you discover that they are adjacent to each other. So aluminium and germanium can be diagonal or can exhibit diagonal relationship. Hence, the correct answer is option B, aluminium and germanium. Aluminium and germanium. Is that okay? So the correct answer here is what? B, option B. If you look at magnesium and germanium, let's see if we can make any sense from this. Magnesium and germanium. This is magnesium, okay? Magnesium is in what group? Group 2, period 2. Germanium is in what? Group 4, period 4. So you see how long it is, the distance. There cannot be a diagonal relationship, okay? So that is that. Now let's look at calcium and gallium. Calcium is here. Gallium, they are all in the same period, so there's no diagonal relationship, okay? So that is everything you need to know about diagonal relationship. Now you may be given different groups of elements. It mustn't be only these ones here. Like I told you that if you look at the periodic table, there are so many diagonal relationships: lithium, magnesium, sodium, calcium, boron, silicon, aluminium, germanium, carbon, phosphorus. All these have that what? Diagonal relationship. Is that okay? So it mustn't be only these ones given. You may be given others. It's just for you to now look at them critically and also have an idea of what the periodic table looks like in case you are not allowed to take the periodic table with you to the examination hall. Have a pictorial representation of the periodic table so that when you are given a question like that, all you just need to do is to align all the elements out and then trace the one that you feel will have the same diagonal or that will have a diagonal relationship between them. Okay? Next question. Elemental sulfur is not topically used as. Now, topical agents, they are agents that are meant to be applied locally on the what? On the skin and not taken orally or inside. Are we getting it now? Those are topical agents. Now, elemental sulfur is not used topically as a fumigant, or no, it's used as a fumigant. It's used as a scabiecide, fungicide, but it is not used as a nematicide. Are we getting it? It's not used as a nematicide, and hence option A is the correct answer to this question. Okay, it's not used as a nematicide. Nematicides are substances that are used to what? Kill nematode or to scare nematode away. Fungicide to kill fungi or fungal infections. Scabiecide, of course, to clear scabies. Then fumigant, of course, everyone knows, to chase away insects and other substances like fumigants like your reed. All those are fumigants to scare away insects and other things. Are we getting it? So those are the explanation. That is the explanation to this question. Elemental sulfur is not typically used as a nematicide. It can be used as a fungicide, it can be used as a scabicide, and it can also be used as a fumigant, but not what? A nematicide. Okay, so that is the correct answer to that question. Now, one of these is used for the treatment of thyroid disorder, iodine. Iodine is used for the treatment of what? Thyroid disorder. Iodine is the element that is used. All these elements here are group 7 elements, but the one that is used for treatment of thyroid disorder is what? Iodine. Hence, iodine is the correct answer to this question. Next, the use of 0.1 molar silver nitrate to quantify chlorine in a compound is called, now the correct answer is argentometric titration. Argentometric titration is a precipitation titration. Are we getting it? In such a way that it will form silver chloride, which is insoluble and can be gotten as a what? A precipitate. So the use of 0.1 silver nitrate to quantify chlorine in a compound is called what? Argentometry. Why? Because silver, the Latin name of silver is argentate. Are we getting it now? So instead of writing silver to metric titration, they use the Latin name, which is argentometric titration. Silver is argentate, the Latin name. So that type of titration is called what? Argentometric. Now, for the first one, EDTA is when you use EDTA as a complexometric agent. EDTA. Acid-base titration, everyone knows this. The reaction between an acid and a base. Redox titration uses different oxidizing and reducing agent for the titration, like MnO4, etc. So this one is argentometric titration as the answer. Now, the next question. Which of the following cation is the most predominant in the intracellular fluid compartment? Now, the cations that are predominant, we have two. We have the sodium cation and the potassium cation. Now, you should be able to distinguish between these two classes of cation. The sodium cation is mostly present in the extracellular fluid, okay, compartment, because the fluid compartment in the cell are divided into two. We have the extracellular fluid, and then we have the intracellular fluid. Okay, the extracellular fluid and the intracellular fluid. So the most predominant cation in the extracellular fluid is sodium, but the one that is most predominant in the intracellular fluid is what? Potassium. So the correct answer here is what? Potassium. Now, what is the most predominant anion in the extracellular fluid? Is chloride ion. Why the most predominant anion in the intracellular fluid is what? The phosphate ion. So you should be able to distinguish between these. This one is what? Extracellular anion. Extracellular, extra. Why this one is what? Intracellular anion. Okay, so that is solution to that question. Now let's look at the next. Give the different types of analytical techniques or method used to assay elements in pharmaceutical substance. We have different types. Now we have volumetric analysis. We have volumetric analysis. Now, under volumetric, you have oxidation, reduction, titration, complexometric titration, argentometric titration, precipitation titrations. All those ones are under volumetric analysis. Then we then have the next one is, I believe, gravimetric analysis. Then we have other instrumental techniques like high performance liquid chromatography, HPLC, and others. There are numerous methods, but these are the ones that I just can't remember now. Gravimetric analysis, volumetric analysis. We have instrumental techniques like high performance liquid chromatography, We can also use spectrophotometry, which is spectrophotometry, which is spectroscopy. Are we getting it? So all these are methods that can be used, or there are different analytical techniques or methods used to assay elements in pharmaceutical substance. Spectrophotometry. Under this, we have atomic absorption spectrometry, atomic emission spectrometry. We have ultraviolet spectrometry, etc. Okay, so all these are methods that can be used to assay elements in pharmaceutical substances. So let's move to the next. List all the group 1 elements in order of decreasing atomic mass. Now let's go to the periodic table. If you go to the periodic table, now atomic masses does what? It increases from top to bottom. Are we getting it now? Increases from top to bottom. It means that all those elements under here, we have the higher atomic mass as compared to the ones that are on top. So when they say in decreasing, it means we start from francium. So in decreasing atomic mass, we can go like this. Francium is greater than what? Cation, greater than rubidium, greater than potassium, greater than lithium. Most times hydrogen is not what? Classified. Okay, greater than sodium before lithium. Greater than sodium, then greater than lithium. Now, hydrogen is most often not classified as a group 1 element, but due to the fact that it has one valence electron, it is included. But most of the properties of group 1 elements are not exhibited by hydrogen. Hydrogen does not have a unique position in the periodic table. Reason being that it can behave as a group 1 element. It can also behave as a group 7 element because it needs 1 electron to complete their atomos share, like the group 7 element. It can also be classified as a group 4 element. Reason being that it needs half of its octet or half of its electron to complete octet, like the group 4. The group 4 needs 4 electrons, which is half to complete octet. Group 1 needs 1, or hydrogen needs 1 electron to what? Complete doublet. It complete doublet. That means 2 electrons in its what? Atomos share. Hence, hydrogen does not have a unique position in the periodic table. So, in order of increasing atomic mass, we can go that we have francium greater than cation, greater than rubidium, greater than potassium, greater than sodium, greater than lithium. So this is the order. Francium greater than cation, greater than rubidium, greater than potassium, greater than sodium, greater than what? Lithium. I believe it's correct. Francium, cation, rubidium, potassium, sodium, lithium. Hydrogen is not part. But if you want to include hydrogen now, you now say greater than hydrogen. But this is not classified as a group 1 element. Okay? So that is that. So this is order of decreasing. Please take note. Decreasing atomic mass. Now, how about if you are asked to specify them in order of increasing? Increasing will be lithium greater than sodium, greater than potassium, greater than rubidium. Increasing will be less than. We are not going to use greater than again. So it will be lithium less than sodium because as it's going, it's increasing. And sodium is less than that of potassium. That of potassium less than that of rubidium. That of rubidium less than that of cation. And this is less than that of francium. And that is the order in increasing atomic mass. So you should be able to identify both of them in increasing atomic mass and in decreasing atomic mass. Okay? Now, let's go to the next. How can the group 1A element be identified via flame test? Now, they can be identified via flame test by passing them through a non-luminous flame. Non-luminous flame of a Bunsen burner of a Bunsen burner. Non-luminous flame of a Bunsen burner. Now, when do you say a flame is non-luminous? Non-luminous, rather. A flame is non-luminous. It means that it produces a very bright and it does not produce a very bright and visible color. It does not produce a very bright and visible color. Okay, now let's see an example. Let me show you an example of a non-luminous flame. Let's see a non-luminous flame from what we have here. Now, if you can see this light here, you discover that this one is bluish white. It's not luminous. Now, let me use this to give an example. You see this one here that is bluish white. It does not have a visible color. This is not luminous. Why this one is luminous? Because you can see the color here. The color here is what? Yellow. Are we getting it now? So this one is luminous. Like the color is very bright. It's something that you can see. So these that are bluish white, that does not pose any color, are said to be what? Non-luminous flame. Is that understood? So that's different between non-luminous flame and luminous flame. So when you pass them through a non-luminous flame, it gives the following. They give the following colors. For instance, sodium, or let's start with hydrogen. Hydrogen does not give any color. Does not give color in a non-luminous flame. No color observed. Are we getting it? So that test does not work for oxygen. Does not work for oxygen. Now, it is their chlorides, not just the elements standing on its own, because those elements that they are very reactive and you can't actually have them separate in nature. They must be in their form, the form of their chloride. Like if you pass sodium chloride through a non-luminous flame, what are you expected to see due to the presence of sodium? Are we getting it now? So lithium, we give crimson color. Crimson. Sodium, we give yellow. For instance, if you use your salt at home, put a non-luminous flame, what you're expected to see is what? Yellow. Then potassium, we give violet. Rubidium, we give red. And then finally, cation, we give blue color. Francium is radioactive. You can't see it in nature. Are we getting it now? It's spontaneous. It's radioactive. This one is radioactive, so you can't pass it through a non-luminous flame. Okay? So these are the various colors that will be seen in a non-luminous flame of their chloride. The lithium will give crimson, sodium yellow, potassium violet, rubidium red, cation blue, francium what? Is radioactive. Are we getting it? It's radioactive. So that is that for this question. Now the next one is this. Enumerate their properties, pharmaceutical and medicinal importance. Enumerate their pharmaceutical and medicinal importance. Now, hydrogen does not have any medicinal or pharmaceutical importance. Does not have any medicinal or pharmaceutical importance. Are we getting it? It does not have any medicinal or pharmaceutical importance. but in the activated form of it, it is used as an agent for the manufacture of acids, base, ammonium, etc. with other salts. Are we getting it? It does not have any pharmaceutical or medicinal use, but when it is activated, it can be used in the laboratory for the synthesis of acid, base, ammonium, etc. ammonium, ion, etc. Now let's come to lithium. The most important pharmaceutical medicinal products or medicinal use of lithium is as lithium triazocarbonate. Are we getting it? Now lithium triazocarbonate is used as a prophylaxis When you say prophylaxis, it means drugs that are taken to prevent specific kinds of diseases. Are we getting it? Drugs that are taken to prevent some particular kinds of diseases. And also it can be used as a bipolar. It can be used to treat bipolar disorder can be used to treat bipolar disorder, which is mania depressive or manic depressive disorder. We also have lithium citrate, etc. All those on their medicinal importance of lithium. Now sodium and potassium, I've already stated this before. Sodium ion is the most predominant ion in what? Is it intracellular or extracellular? In extracellular fluid. Is the most predominant ion in extracellular fluid. And then potassium ion is the most predominant ion in intracellular fluid. Okay? The most predominant ion in intracellular fluid. Is that okay? Now, the official compounds of these elements, they are listed. If you check the material, you are going to see them there. The official and the unofficial medicinal compounds of them as compounded in the British Pharmacopoeia or the USP, United States Pharmacopoeia. So let's go to the next. Now, a solution is prepared by dissolving 2.0 gram of silver nitrate. So the amount given is 2.0 gram of silver nitrate in 250. The volume is what? 250 milliliter volumetric flask diluting to volume. Calculate the molarity of silver nitrate. Now the first thing we need to write is the formula for molarity. What is molarity? Molarity is equal to number of moles all over the volume, either in liter or in dm cube. Molarity is equal to number of moles all over the volume, either in liter or in dm cube. So it means that we have to convert this milliliter to liter by dividing by what? 1000. And when this cancels this, it's going to give us the volume as 0.25 liter. But you don't know the number of moles. But we know from our primary school that number of moles is equal to mass all over molar mass. The mass was given to you, but you don't know the molar mass of silver nitrate. Now to calculate for the molar mass, we come here and say molar mass of silver nitrate. Now, silver was given to us as 107.87. So we are going to use 107.87 plus the molar mass or the atomic mass of nitrogen is 14. That of oxygen is 16. 16 times 3. So this gives us 107.87 plus 14.16 times 3 is what? 48. And when you add everything here together, it's going to give us, when you added them, it gave 169.87. So that is the unit is gram per mole, of course. So that's the atomic mass of, or the molecular mass of silver nitrate. Molecular mass of silver nitrate, okay? 169.87 gram per mole, exactly. So we are now going to come here to calculate for the number of moles. The mass was given to us as what? 2 grams. So we say 2 grams. The molar mass is what? 169.87 gram per mole. When this cancels this, what is it going to give to us? So we have 2 grams divided by 169 gram per mole. 2 divided by 169.87 gram per mole. So the molarity is 0.0117 mole. So we are now going to come here. Let's go to a fresh sheet. So we know that molarity, normally our molarity is equal to number of moles all over the volume, either in liter or what? dm cube. Now the volume, we already calculated it as 0.250 liter, which is what we converted here. Now the number of moles, we already calculated it as number of moles is already calculated as 0.0117 mole. So our molarity now will be equal to, number of moles is 0.0117 divided by the volume is 0.25 liter. So from here we can say that our molarity is equal to, when this divide this, what is it going to give to us? Let's do that quickly. 0.0117 divided by 0.250, which will give us 0.0468 molar. So the correct solution to this question is molarity is equal to 0.0468. You can put molar, or you can say mole per what? Per liter. See that you say molar or you say mole per liter. Is that understood? So that is the solution to that question. I believe that is all for now. Thank you for staying to the end. Make sure you subscribe to this channel. Turn on the notification button so that you'll be notified whenever we post a new video. Now you can decide to go through this particular video again, this particular calculation again. It's a very simple thing. You will enhance to calculate for the molarity. You know that molarity is what? Number of moles over volume. Now the volume was given to you in milliliter. When you are talking about molarity, the volume should be in dm cube or in liter. So we have to convert our volume from milliliters to liter by dividing by 1000. And when we divided by 1000, it gave us 0.25 liter. So from there now, we also need to know the number of moles. But the number of moles was not given to us. But we know from relationship in the past that number of moles is what? Mass over molar mass. The mass was given to you. The molar mass is something you can calculate for by adding the atomic masses of each of the elements. So when we added the atomic masses of each of the elements, it gave us 169.87 gram per mole. Are we getting it now? So our mass, all over molar mass, will be 2 grams all over 169.87 to give us 0.017 mole. We came here, wrote all parameters out again, then substitute. Number of moles is 0.0117 mole divided by the volume is 0.25 liter. When we calculated, it gave us 0.0468. You can put molar or you can put mole per liter. And that is the solution to all these questions. Thank you for your time.